This video is on the vocabulary of probability. We're going to look at two kinds of probabilities, theoretical probability and experimental probability. You might want to pause the video and copy down the definition of theoretical probability. So theoretical probability is the extent to which an event or outcome is likely to occur, measured by the ratio, which is better written as a fraction, of favorable outcomes to the total number of possible outcomes. So I just want to highlight something, total number. So vocabulary is important, and understanding the definitions are important, but perhaps an easier way to understand that nasty sounding definition is just to give you a little formula. So here's our theoretical probability formula. P stands for probability. So the probability of an outcome. An outcome is just what you want to happen. You know, flipping a coin, is the outcome heads or is the outcome tails? Rolling a die, is the outcome 1 or 2 or 3 or whatever? So the probability of an outcome, the probability of something happening, is simply equal to the number of favorable outcomes, like the number of ways to get what you want, the number of favorable outcomes divided by the total number of possible outcomes. So for example, if we were going to flip a coin and we want to know what is the probability of getting a head, well, there's only one head on a regular coin, and there are two possible things that can happen. You can get heads or tails. So again, the top number represents the total number of ways, the number of ways you can get what you want, and the bottom represents the total possible outcome, the total number of possible outcomes. So you probably know this already. Okay, experimental probability. Again, pause the video and write down the definition. Experimental probability is the extent to which an outcome is likely to occur as determined through an actual experiment or action. So this is kind of the same as above, but not exactly. So here would be our little formula. The probability of an outcome is equal to the number of outcome occurrences. So you're going to actually do an experiment, and you're going to count how many times you got what you're trying to get. So the number of outcome occurrences divided by the total number of trials. So how many times did you flip a coin? How many times did you roll a die? How many times did you spin a spinner? And then finally, the sample space is a little bit different than the total number of outcomes. The sample space is the set or list of all possible outcomes. It's not the number of possible outcomes, although sometimes that is the same. It is actually what's happening. So a few examples then. So for example, if I said we're going to flip a coin, what is the sample space for when you flip a coin? Well, you can get a head or a tail. So the sample space is heads or tails. The number of possible outcomes is 2. Well, what happens if you roll a regular die? Well, the sample space is you can get a 1, 2, 3, 4, 5, or 6. So again, there's 6 possible outcomes, and they match the sample space in this case. One last example of sample space when they don't, you roll a pair of dice. So when you roll a pair of dice and you add the numbers together, much like you would have done in playing board games, then here is what can happen. you can get these numbers right here. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's impossible to get a 1. It's impossible to get something bigger than 12.